All right, today we are looking at the single replacement reactions lab. All right, so to begin with, a single replacement reaction is a chemical reaction where one reactant is exchanged for one ion of a second reactant. It's also known as a single replacement reaction. So we have two general equations here, one shown in some pictures, and then our general reaction of A plus B, or compound AB plus C, reacts to form compound AC plus B. Here's another example of a reaction between iron 3 oxide and carbon. Is an example of a displacement of iron from the iron 3 oxide solution by carbon. When you look at a chemical equation for a reaction, a single replacement reaction is characterized by one cation or anion trading places with another to form a new product. It's easy to spot when one of the reactants is an element and the other is a compound. Usually one of the two substances react. The cation or anion will replace the less reactive ion within a compound, always that of the same type of element. A metal would replace a metal, a nonmetal would replace a nonmetal. You can predict whether a single replacement reaction will occur by comparing the reactivity of an element using an activity series. In general, a metal can replace any metal lower in the activity series. The same rule would apply for halogens or anions. So the purpose of this experiment is to develop a basic activity series based upon the observations collected during a series of single replacement reactions. So after we've read through the entire lab and highlighted the background and the procedure to identify all of our actions for today, we're going to go ahead and get started. Okay, so for the lab today, we are working with zinc sulfate, okay, which is this solution right here. It's odorless and colorless. Then we have copper 2 sulfate. Again, this blue solution. We know copper solutions are always blue. All right, and then we have magnesium nitrate, also a clear solution, and then we have hydrochloric acid, which is this, another clear solution. All right, so in the lab, what we want to do is take a tiny piece of each metal and place it down each column. So the first one we have is zinc. This is granular zinc, so little teeny pieces of zinc. So I'm going to place a pile in each spot down the column here. Okay, so we can see that the zinc is silver, slightly shiny. Then we have magnesium here, or actually let's do copper. This is our next one. So we have some copper. These are little kind of granular copper. Okay, and I'm gonna kind of do this, get them out. There we go, a little pile of each. Okay, this is our copper, kind of what we recognize as the copper color, shiny, little pellets is kind of what we have. So I'm going to put the pile a little more together here. All right, and then we have magnesium. So this is magnesium. It's we call magnesium turnings, just little pieces of magnesium. So kind of like the ribbon, but not nice and flat like we were using last week. All right, so that gives us plenty in each spot here. All right, let's put it all together. All right, so those are our three metals. So for our observations, if we're taking a look at our data table. So in my data table, I'll show you what it looks like. So here we have, this is what you should have in front of you at the moment. All right, we're going to write no reaction, or you're going to describe what's happening for each one of these reactions. Okay, so I'm going to go ahead and take my zinc sulfate, and I'm going to put several drops across the top. And it says that I want to add 2 or 3 drops to each one, which is what I will do. Okay, and we'll look to see if anything happens. All right, so that's with our zinc and our copper, and then our magnesium here. Okay. All right, so I'm going to move my camera here. Hopefully you can see a little bit better. Actually, let's go through and put these all in, and then we'll give a minute to pan down and see all of our reactions. Okay, so that was the zinc sulfate. Now we've got the copper 2 sulfate. Do the same thing. I'm going to put a couple of drops in each area. Ooh, there we go. That's in our, maybe you can hear that sizzling a little bit. All right, and then we have some magnesium nitrate here. Again, 2 or 3 drops in each spot. All right. And then finally, let's do our hydrochloric acid with our zinc. And then the copper. And then with, ooh, there we go, our magnesium. Ooh, you can't smell that, but it's got a little bit of an odor there. All right, so let's just pan so that we can see some observations here. So this is our zinc with the zinc sulfate. Looks like there's no change, okay, no reaction. With our copper, not seeing any changes there either. And then you can see with our magnesium, hopefully it shows through, but we have a darker gray. There's bubbles being produced as well. So that was the zinc sulfate. Now we have the copper 2 sulfate with the zinc. You can see that looks like dark black. There are a little bit of bubbles there as well. Then we have the copper with the copper 2 sulfate. Nothing is occurring there. And then we can see with the magnesium, if you remember, it was that nice silver-ish color, and now we've got a big pile of black. Okay, a little bit of bubbles there as well. All right, then we have the magnesium nitrate with each of our metals. So this is the magnesium and the zinc. Nothing has occurred for that one. The copper 2 chloride, again, nothing has occurred, so no reaction there. And then the magnesium and the magnesium nitrate, again, no reaction there. It's a little bit difficult to see, but trust me, I still see the shiny silver there. All right, and then finally we have our hydrochloric acid and zinc. So there are bubbles being produced. I can see that. Okay, so we definitely had a reaction there. Then I have my copper and my hydrochloric acid. No reaction, that still looks the same. And then here, again, was my magnesium and the hydrochloric acid. I'm going to do this again with a little bit more so you can see definitely a big violent reaction. Lots of bubbles. There's gas being produced, which I can get a kind of odor from that as well. All right, so those are the reactions that I have. Okay, so we had several that were no reactions, and then a few that I did have a reaction. So hopefully you were able to write that down in your data table. If not, go back and rewatch the video again. All right, so I will go ahead and clean this up for us. Now your job is to take a look at the post-analysis questions here. You're going to be submitting on Canvas, so you're going to see these questions there to fill in. Okay, so the link will be there. One of our, all of your questions should be able to be answered just by taking a look at your data here. All right, so that was the single replacement reactions lab.